Okay, welcome back into part 2 of our notes on logarithms or logs. Today we're going to look at graphing logarithms. So, in addition to calculating, we can graph them. With graphing, right now we're going to look at the default base of a log. So the default base of a log is 10. Log of x has a base of 10. So when we don't put a base there, we assume the base is 10. So, with that being said, let's take a look at the two graphs together. So over here, you will see my equations I have in purple, this log graph. Over here in teal, I have this 10 to the x, and then I have the line that all inverses reflect over, y equals x, dashed here. If you notice, if I were to fold along the dashed line, they would appear to fall on top of each other. So these graphs have what are called asymptotes. Right now, I'm just going to look at the purple graph, the log graph. The log graph has a vertical asymptote at the line x equals 0. So that means on the y-axis, there's a vertical line that goes up and down that this graph will approach but never cross. So, when we draw these and we make sketches, we must be very careful and deliberate here. We must draw the asymptote. I will always draw it with a horizontal, this is a vertical asymptote. I will always draw it with a vertical dashed line. Please draw that accurately. Point number 2 about the asymptote. You must never cross the asymptote. The asymptote is a line that it approaches but never crosses. We can also see that it does have an x-intercept right here at 1, 0. So that's going to be our default x-intercept. So if I move it to the right, I'm just going to add, or if I'm moving it left or right, I'm going to add or subtract to the x value. If I'm moving it up or down, add or subtract to the y value. So, a few more things. The domain. I cannot have negatives inside my logs. I cannot plug a negative number into a log function. It will not work for us. So the domain is x is greater than 0. The range, however, is all real numbers because it does go up forever. So when we look at a graph, if we have y is equal to a times log of x minus h plus k. These 4 letters, a, x, and k, will move this function. So a is a little odd. A will either reflect stretch or compress. So it stretches when the number's bigger than 1. It compresses when it's between 0 and 1. If it's negative, it flips it over. Stretch, stress, compress. Now, H is one we have to be very careful about. H moves it in odd ways. H moves it left and right. Typically, when we think of a positive number, we think of, on the x-axis, positives are on the right, negatives are on the left. However, since this is inside the function, it works in reverse. If it says x minus something, that actually moves it to the right. X plus something moves it to the left. So it actually moves backwards, so we need to be careful about that. Now, the K will just simply move it up and down. The K does not work backwards. K works in a typical fashion. So, if we're moving it up, we want to add to it. If we want to move it down, we subtract. So, with this, we are going to look at, and I'm going to do rough sketches by hand. Since I know you might not have graph paper at home, I'm going to show us how, hey, even on something, you can make a nice rough sketch and include all the important details you need, mainly just your asymptote and your x-intercept, or the movement of your x-intercept. And I will consider that an accurate graph. I will also show us how we can look at it on Desmos too. So example A. Example A says we have the log of x minus 4. Okay. So, since there's no number in front, there's no stretch or compress. Since there's no number in the back, it does not go up or down. But since there's a number inside, it tells me, since it's a minus 4, it's moving right 4. So I would like you guys, when you are doing your problems, to also include, just say, hey, this is the transformation. It goes right 4. So this way, even if you have some inaccuracies with your graphing, I know what you're trying to do and can give you partial credit there. So, I just need to move right 4. The horizontal asymptote, or sorry, this is a vertical, it's not an exponential, it's a log. The vertical asymptote is usually x equals 4, or sorry, x equals 0, but since I move it right 4, this now goes to x equals 4. Actually, let me write that down. So it went from x equals 0. If I'm going right 4, I need to add 4 to my x. So that's x equals 4. So how I'm getting that. Now, my x-intercept usually is, let me write it down, vertical asymptote. Default is x equals 0. X-intercept defaults to 1, 0. So I need to add 4 to my y-intercept to get the point 5, 0. So what I'm going to do is draw a rough sketch, add my asymptote, add my point, draw my curve. So I don't have graph paper on here, but it's okay. 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5. Okay, 6. So I have enough space to do this. I want to start with the vertical asymptote. The vertical asymptote happens at x is equal to 4. So I'm just going to sketch a vertical line like so. So now that I've sketched my vertical line, what I'm also going to do is plot my x-intercept. 5, 0. Now that I have my asymptote and my point, I want to carefully move along the asymptote up to the point and turn here. Never cross the asymptote, but you want to get really, really close to it. And that's the sketch of this graph. So that's one example. I got 2 more for you. This way we can see what other things like stretches will look like, what moving up and down will look like, and what reflections will look like. But for right now, hey, I moved my vertical asymptote, I moved my x-intercept, because both of those can be affected by moving them to the right 4. Let's look at example B. Example B states that we have the log, 6 times the log of x, and then outside the parentheses a plus 3. So since I have a number in front, and since it is a number bigger than 1, this tells me it just stretches vertically. So I want to draw this kind of taller, a little more exaggerated going up. Exactly how much more I'm not going to be super stressed out about, but just enough showing that, hey, it seems to grow faster. Now there's something inside with the x, so it doesn't change its left or right position at all. So I know my vertical asymptote will not change, and the 1 in the x-intercept won't change. But if I do this plus 3, it will affect the y value here. So the plus 3 tells me I go up 3. So here's what I'm going to do. Going to start again. Since this does not move left or right at all, my vertical asymptote is just x equals 0. Now my x-intercept, it doesn't move left or right at all, so this piece will not be affected. It's still going to be 1, comma, but since I move it up 3, it no longer becomes an x-intercept, it just really becomes a point. So I'm just going to call this a point. So since that x-intercept went up 3, I'm going to call that 1, comma 3. So I know that x-intercept got moved from 1, 0 to 1, 3 just by a vertical shift upwards. So let's take the time to do our rough sketch. Now, I know my vertical asymptote is right here on the y-axis, because that's x equals 0. Now, the point I have, 1, comma 3, is going to be up here. So what I'm going to do, I'm going to make sure it stays along here a little longer, going up to this point, that's going to go off a little faster than the other one did. So it might look something like this. And if we look at this on the Desmos calculator, let me take the time. Let's see, we have y equals the log, I want to delete log, y equals 6 times the log of x, x, close parentheses, plus 3. You notice how this one actually has a y-intercept there? That's why calculating the y-intercept is going to be a pain. But if I go here, I do see the point 1, comma 3. And as I said, this goes up a little faster, so I drew it a little exaggerated going up a little faster. Now we got one more example to look at, and then we are done with graphing. I'm going to ask you to give the work a try. The next one just looks at reflecting it over the x-axis. So the next one just says the log of negative log of x. So it just says negative log of x. So the negative, this is an example C. So the negative log of x, this tells me this just reflects. So since it is reflecting, I don't have my vertical asymptote change. I don't have my x-intercept change. It goes from going up to going down. So, vertical asymptote is still at x equals 0. X-intercept is still 1, 0. And so I'm just going to do a very quick sketch here. It's the one that's not as bright. So I know I have my y-intercept here. I know I have my vertical asymptote going down here. Since this is reflected, usually it goes up. This one is going to go down, like so. And here we will take a look at this quickly in the calculator. So right now we see it as just the log of x. If I throw a negative sign there, you see it flip over, just like I flipped it over here. So that is all we're starting with logarithms. I hope you found these videos informative and helpful for your homework. Thank you. Have a great day.